12, 4, 4 is 8, okay. 13 times 12 is 6, and 4 times 12. Something's off. Or is it just right and I'm overthinking it? 114 where? I don't see 114 up there. Fill in the boxes. Alright, so we got, let's count this out. Where did I think it was wrong? I thought that, what do we got? Fill in the boxes at 8. Alright, boom. 40, 48, 4, okay. 6, okay. 8, 6, 4, this should be 2. You see the pattern? 0, 8, this should be 6, this should be 4, that is 2. 0, 8, 6, 4, 2, 0. Got it? Next should be 1, 2, 3, 4, 4. Why are these 2 4s? Ah. Same reason this is not 15, 16, 17. This held up this jump because it's less than, it's 2 less than 10, and this is 1 more than 10. So this held up and this proceeded. Yes. Let's fill in the boxes for 8. So we have 2, we have 1, 2. Before I put a 3 here, yeah, it should be 3. 4. This is going to be 56. 5. But you see how it 4, 4. 1, 2, 3, 4, 4. 5, 6, 7, 8, 8. 9, 10, 11, 12, 12. I bet you 9 times out of 10, this is going to be a 12 down here. What's 120 plus 8? 128. Look at that. 12, 12. So the next one that skips, it should be 16, 16. Where would it skip? It would skip at this would be 16, 17, 18, 19, 20. Somewhere down here is going to be 16, 16. Let's look. 16, 17, this should be 13, 14, 15, 16, 16. So this is going to be at 17. This is going to be at 18. This is going to be at 19. This is going to be at 20. It's going to skip at 20 and 21. 21 times 8 is going to be something 16, something 16. See it? Let's look. 10, 11, 12, 13, 14, 15, 16, 13, 14, 15, 16, 16. Then this is going to be, what do we got here? 8, 6, 4, 2, 0, 8, 6, 4, 2, 0, 8, 6, 4, 2, 0, 8, 6, 4, 2, 0, 8. So 128, 136, 144, 152, 160, 168. You see that? Everything has a pattern in this table. We just didn't know it. Once we find the mental construct, we could build it in our mind. I built this into my mind when I was my kid's age. But I didn't know anything outside of this, or why it is, or why numbers add up to what they add up to, or why they multiply into what they multiply into, and the same as why they divide into the same multiples, divisors, excuse me. 28, 42, 55. What? No, 28, 36, 44, 52, 60, 68. While he's writing that, it's okay. It'll become clear. Let's keep going. Sevens. We're missing some stuff here. 7 times 4 is 28. Until we get into the double digits, we don't even need to think about mental constructs. 7 times 5 is 35. Alright, and we got 7 times 8 is, where you at? Oh, 7 times 8 is 56, right? 56. Excuse me. And 7 times 9 should be 63. No. Why is that round? That's not in round, bro. 7 times 9. Yeah, 63. 63. Alright, we're counting by 7s. Count by 6s. 6, 12, 18, 24, 30, 36, 42, 48, 56. Excuse me, 54. 60, 66, 72. And this should be 78. 84, 90. Okay? Count my 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60. Count my 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, and 45. Count my 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Start by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. See how it became increasingly easier to count, to skip count? We was doing 5, 10, 15, 20, 25, 30, 35, 40. That's easy. 10, 20, 30, 40, 50, 60, 70, 80, 90. That's easy. It got easier with the bigger multiples. 100, 200, 300, 400. It got easy. Why? 55, 10, 20, 30, 100, 200, 300. It's as if I'm counting. No, I'm not going to go into that. That's theoretical. But we were taught to count by 1s easily, 2s a little bit harder. Most people don't know their 3 timetables. They're 3 multiples. It's like it's harder, right? A lot of people know their 3 timetables, but who knows their 4s? Most people know their 5s. So we were taught in spurts. We were taught little bit by little bit. We were taught to count by 1s. We were taught to skip count by 2s. We were tongue-tied. We were taught to count by 5s, 10s, 20s even, 50s even, 100s even, but not in the middle. And nothing past 12. Is that systematic? I think it's just that we were supposed to fill in the blanks in the meantime. Well, the most commonly used things are 1s, 2s, 5s, 0s. Makes sense to me. I mean, what numerical system do you know operates by 7s or 6s? or 9s or 8s or 4s or 3s. It all operates on a 1 digit or a 5 digit, 5, 10, 15, 20, right? A 0 digit, 10, 20, 30, 40, 50, or 100, or 50s or 100s. I think we were taught what we needed to be taught. Well, we were taught what we needed to know based on the applications and the uses. You were taught ones because certain things are based on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Such as a clock. You were taught 2s. Oh, we taught 2s. 2, 4, 6, 8, 10, 12. What is that? I don't know. We'll go back to that. You were taught 5s. 5, 10, 15, 20, 25, 30. I don't know. I'm just thinking of theories of why we were taught what we were taught. There are reasons. They're just not coming to mind right now. Metric system, imperial system, your measurement, your measures, your liquid measure versus dry measure. I'm going off on a tangent here, guys. You're supposed to stop me. You're supposed to stop me. All right, let's get back to it. My brain can run all day on why. 15, 28, 39, something, 55, 60, 63, 64, 63, 60, 55, 48, 55, 48. Because 12 times 4 equals 48. 2 times 4 equals 8. 1 times 4 equals 4. 4, 8. What we got here? What's this? 77, 80, 81, 80, 77, 72, 65, 56. This is going to be 88, 90. Oh, excuse me. 88, 90. 90, 88, 88. We're on the wrong one? We're going this one. Oh no, we're going this one. Excuse me. 77, 80, 81, 80, 77, 72, 65, 72, 65.
$78.
56. Because 14 times 4 is 56. Because 4 times 4 is 16. Carry the 1. 1 times 4 is 4 plus 1 equals 5. 56. 65. Because 13 times 5 is 3 times 5 is 15. Carry the 1. 1 times 5 equals 5 plus 1 equals 6. 65. 72. Because 12 times 6 is 6 times 2 is 12. Carry the 1.
78.
6 times 1 is 6 plus 2 plus 1 equals 7. 72. What do we got here? 12 times 7 is 4. Carry the 1. 14. 7 times 1 equals 7 plus 1 equals 8. 84. What's this? 13 times 6. 3 times 6 is 18. Carry the 1. 6 plus 1 equals 7. 78. That seems wrong. It is. Because 3 times, that's a 6, right? No, that was right. 78. I'm thinking of a 7 times 3 equals 21. It's not. 3 times 6 is 18. Carry the 1. The 8, carry the 1. 8 plus 6 plus 6 times 1 equals 6 plus the 1 equals 7, 78. What's this? 14 times what? 5. 4 times 5 equals 20. Carry the 2. 5 times 1 equals 5 plus 2 equals 7. What's this? 13 times 4 is 3 times 4 is 12. Carry the 1. 4 times 1 is 4. plus the 1 is 5. 52. We're almost there, kids. I literally think we only have like 8 more boxes. Ooh. Interesting. Muy interesante. Interesante. To you, my friend. What's this? 14 times 8. 14 times 8 is 4 times 8 is 32. Carry the 3. 1 times 8 is 8 plus 3 equals 11. 13 times 9 equals 3 times 9 is 27. Carry the 2. 1 times 9 is 9 plus the 2 is 11. And we have 13 times 11. What? 13 times 12. 13 times 12 is 144 plus 13 plus 12 is 156. How do I do that? 144 plus the next 12 is just 1 up. 2, 4, 6. 13, 14, 15. This is 16. 8. 18. 10, 12, 13, 14, 15, 16, 80. Why? Because we're going to skip that. Remember, it skips. Watch. Look up here. 12. That's 1, 2, 3, 4, 6. See how I skipped? 7, 8, 9, 10, 12. Right? 13, 14, 15, 16, 18. See how I skipped? It skipped 2. Every 5. That's the secret of 12. Who knew? We could go on into infinity, right? We know what's next. It would be 19, 20, 21, 22, 25. You want to prove it? Let's prove it. 19, 20, 21, 22, 20. Oh, wait, what did I say? Did I say 25? No. I meant 19, 20, 21, 22, 24. Now watch this. Those are these are the 100 place. This is the tens place, and we're missing the what place? What place are we missing, guys?
1, 9.
The ones place. Yes, you're right. So how was the one place derived? 2, 4, 6, 8, 0, 2. What is this? Huh? 2, 4, 6, 8, 0, 2, 8, 6, 8, 0, 2, 4, 6, 8, 0. Something in here is wrong. Let's fix that. 2, 4, 6, 8, 0, 2. This should be 4. This should be 4. See that? See how I messed up? I didn't go to 77, I go to 78. It's a factor of, it's a 7. The 12th 7. This is the 7th 7. You gotta look. You gotta look what you're looking at. Look what you're looking at. They need to see. This is the 7th 7. We messed up here. Why? I can tell. 70 goes to 77, and then it goes to 84, not 88. How did I know that? Because of the numbers that we just said in the ones place should go 2, 4, 6, 8, 0. 2, 4, 6, 8, 0. 2, see? But I had 8 there. That's how I knew it was wrong. 2, 4, 6, 8, 0. This should be a 2. Making 192. This should be a 4. Making 204. This should be a 6. This should be an 8. This should be a 0. Okay? Now this is wow. 12 times 16. Maybe we should clear this up a little bit. At least momentarily. As soon as it dries, it'll mess up. But anyhow. Oops. 26, 22, this should be 21. Okay? Yeah, I know this is a weird way of doing it, but I can project what it would be without the actual multiples based on a pattern. 13, so 12 times 16 is 192. 12 times 17 is 204. 12 times 18 is 216. 12 times 19 is 228. 12 times 20 is 240. How do I know 12 times 20 is 240? Because 12 times 2 is 24. But I had a 0. I chopped it off. I put it back. Boom. Okay? See that? We know it's right. Numbers do not lie. People do. Numbers do not. Hands do. So you fix it. Go back through. Okay? Let's run through again. What do we have here? 13s. Let's sense the pattern and finish these through a pattern. Okay? In the ones place. Coming up we have 1, 2, 3, 5. That's odd. 6, 7, 8, 10. No. 6. Wait, what? 1, 2, 3, 5. 6, 7, 9, 10. 1, 2, 3, 5, 6, 7, 9. It jumped. 10. So this should be 11, 13. This should be 15. No, that's right. 14, 15. No, I'm sorry. We're doing that wrong. 1, 2, 3, 5, 6, 7, 9, 0. 1, 3, 4, 5. Let's do it in ones. 3, 6. What is it? 3, 6. Is that a 9? Yeah. 3, 6, 9, 2, 5, 8, 7, 4, 7, 0, 5, 6. There's no pattern there. When there's no pattern, there's a pattern to no pattern. There has to be a pattern to no pattern. It's just we haven't factored it all the way out until we see the repeat. In numbers, they repeat. If it's structured in this format, which is structured, there will be a repeat. It's just we don't have enough space to do it all. Alright? Now we're getting way out there, so our patterns may be less obvious up close. If we zoom out and pan out, and we see a bigger number table, we'll probably be able to see the pattern. But up close, all of these should be predictable. Like up here. Let's say I wanted to do 3s. Right here, we have 3, 6, 9, 2, 5, 8, 1, 4, 7, 0, 3, 6, 9, 2, 5, 8. See how I did that? You think it's unpredictable, but it's not. The next one should be a 1. The next one should be a 4. The next one should be a 7. The next one should be a 0. The next one should be a 3. The next one should be a 6. The next one should be a 9. The next one should be a 2. Let's prove this. Are you ready? Here. There's nothing here, nothing here, nothing here. There's a 1, 1, 1. 2, 2, 2. 3, 3, 3. 3. So, 0, 0, 0. 1, 1, 1. 2, 2, 2. 3, 3, 3, 3. 4, 4, 4. 4. Nope. Just a 4. 444. We're gonna go down now. 000 111 222 3333. 444 5 5 5 6 6 6 6 7. I want to know what the so it's 000 111 222 3333 444 555 6666. There's a pattern there, but these are the correct answers because you have 17 multiple, 18 multiple, 19 multiple, 20, 21, 22, 23, and the 24. Turn the camera. I think I heard my name. And we're back. Sorry for the brief intermission. But I just started to prove some things that now, instead of just doing this graph, this number, this multiplication table, it goes out. It goes out. And it can be proven based on patterns in the ones place, tens place, and hundreds place. Based on patterns. There's patterns in those numbers as well. If you ever looked at it like that. Okay? I think this is how some people's brain works. That's why you're like, what's 1 billion? And they'll tell you. And it'd be right. And you're like, how do they do that? Their brain works like that. So, it's not that they memorized it. They figured out the formula. The formula is in their brain. Not the answer, the formula. So if you ask them the question, the answer pops out of their head, it pops out of their mouth. Because the formula is in their brain. Okay? 13 times 13 should be something with a 9. Okay? You're going to skip 3 times 9 is 7. 7 is 4. The next one should be a 4. Yeah? And the next one should be a 6. Next one should be a 6. And the last one should be a 1. 169. Look at that. 168, 169, 168, 165, 165. Okay? 180, 180. So what's in the middle? Let's look up. 14 times 14 times 13 is what? 14 times 13 is something with a 2. 11. Wait, 9, 11, 13, 15, 16. Fill in the blanks. Wait a minute. Well, this should be 17 then. Let's go up. 3, 5, 7, 9, 1. We're looking at the tens place, not that. 9, 1, 3, 5, 7. That should be a 7. 7. Should this be a 9? No. 172. Let's see. That's the right answer. 11, 12, 14, 15. 11 up. Mute. Anyhow, the home is not a studio. Okay? You have kids? I have 6. You might see my face change every once in a while. It's just human. Alright, so what do we have here? 13 times 14. Didn't we already say that? 14 times 13? And is it 172? Let's check. 14 times 13. 12. 4. 4, 1, 2, 8, 1. That is not where I thought it was going to be. But I thought it was going to be different because you can't go from 15, 17, 21. It's got to go 15, 18, 21. 3, 3. So this should be 182 as well. Okay. So like I said, some patterns you can see, some patterns you can't see. 195, 195. What is this? 196. Let's go this way. One, two, four, five. Oh, 1, 2, 4, 5, 7, 8, 9. 1, 2, 4, 5. This should be a 7. No. Because everything isn't all theory. I mean, I guess all theories aren't true in every instance. I thought that in the tens place it would say the same. 1, 2, 4, 5, 7, 8, 9. 1, 2, 4, 5, 7, 8, 9. I would think this would be a 9. And I thought that would be a 7. Thought that was a 7, but it's not. Because 132 and 144 and 156 and 168 and 180 are all correct. So it's not a 7. I'm disproving in the so I guess that we're gonna skip that 8, that 9, and then 1. Why not? I dare to question this anomaly that's no longer going to be a 7, which is a 7 right here. I want to pair the numbers to reasons. So we have 2 here. We have 1, 4, 1, 5, 1, 6, 1, 8. 1, 11, 12, 14, 15, 16, 18. 11, 12, 14, 15, 16, 18, it should be 19. Then it skips to 21. 2, 6, 0, 4, 8. 2, 6, 0, 4, 8. So this should be 196. Did I say 196 before? I think I said 196. Go back in the tape and see. Alright. Let's see if this is correct. This is a number totally derived off of patterns we're putting out there. Now let's see if it's correct. 14 times 14 equals 16, carry 1, 4 is 5, placeholder 4, 1, 6, 9, 1. I don't know. So, some theories you make and then they break. And some theories you make and then they take. Others you have to shake. Don't bake. Alright, look. Now I love baking. Yeah, we're pretty much done here, guys. We did the whole thing. Alright, we did the whole thing. I'm pooped. This is Weldon Work Online. Weldon Work. Check out my YouTube channel for amazing tips and techniques on how to live a more productive life, how to learn how to eat healthier. I have a health and wellness channel on Instagram, Weldon Work Health and Wellness. You want motivation? Go to Weldon Work Motivation on Instagram. And if you want to learn about cryptocurrency and making money online, go to Weldon Work Online. And all those on Instagram, my Instabrands. But I broke them up like that on Instagram because each feed needs its own thing. But YouTube has this conglomerate. I put all my videos on YouTube. So whether it be cryptocurrency and making money online, which we have a Make Money Online with Weldon Work in 2020, we have that show. We already did that. We did like 20, maybe 18, 20 segments. Maybe not even that much. But it has a big orange background. Check it out on YouTube if you want to learn how to make money online. Also, tips and tricks on like how to, be calm, deal with anxiety. I do a lot of motivational speaking on there. Have some motivational speaking, and as well as health and wellness. Make sure that you are eating your greens. Drink your mangoes. I got one on there called Drink Your Mangoes. Kids like that one. It's just a whole bunch of me on there. But aside from me, it's what it is that I've found in life to work. Or that's, I think is cool. Just my own perception of what I think is cool. I think this is cool. So we did it today. Alright? On my son's wall. And I'm pretty sure he's going to use this chalk to finish the rest. Into infinity! See y'all later.